everyone. In this video, let's talk about the midpoint formula. So we already know what a midpoint is. A midpoint is the point that is right in the middle of a segment. It divides that segment into two congruent halves. Okay. Now let's talk about the midpoint formula. So we want to be able to use the midpoint in the coordinate plane. So we're going to come up with a formula using x's and y's that will allow us to easily find the coordinates of the midpoints. So let's start by looking at a generic graph. So let's start with some axes. And I'm going to put a segment in here. And this is just going to be arbitrary. So this segment could exist anywhere in the coordinate plane. It doesn't matter. So I'm going to put a point here. And then we'll put a second point somewhere like this. And let's say that this is point A, and we have point B, and then let's connect this together to form a segment. Okay, the next thing we want to do is we want to assign some coordinates to our 2 points. I do want this to be general. I want this to be arbitrary. So let's use some variables. So for point A, let's say that this is the point x1, y1. And for point B, let's say that this is the point x2, y2. By choosing variables as our points, as the coordinates here, that means that this could be anywhere. The x's and the y's, they could be positive, they could be negative, it could be any combination, so we're keeping it arbitrary. All right, now let's think about the midpoint a little bit. We know that the midpoint is supposed to be right in the middle of this segment. So after we split it up, we end up with 2 congruent halves like this. But I want to find the coordinates of this point. So let's just focus on the x values first. So if I drop down from point A all the way to the x-axis, on the x-axis, this has a value of x1, right? It would take me x1 units to get to where point A is. If I drop down from point B and go all the way down to the x-axis here, this x value is going to be x2. Same idea. Now if I look at where my midpoint is, if I drop down, I want to know what this x value is. We do know that the midpoint has to be the same distance away from these 2 endpoints. So the length here should be the same as this length. So these should be equal to each other. Well, another way that we can find the middle is with an average. So remember, the average is when you add up however many things you have, and then you divide it by that number. In this case, our number is just 2. So I'm going to add up the x values and divide by 2. So if I do x1 plus x2, and if I cut that in half, that will give me the middle in between x1 and x2. So this is the average of the x values. Okay, let's do the same thing for the y values. So again, if I go straight across to my y-axis, the y value here has to match up with the y value for A. So this is y1. If I go all the way across from B, the y value here has to match up with the y value for B. And then right in the middle should be the y value for our midpoint. So then this point, the same exact argument we made down here for the x's, this point should be the average of these 2 y values. So this is y1 plus y2, and then we'll cut that in half to find our average. So average of y values. Okay, so again, these 2 distances, so in between y and then the middle and then y1 in the middle, those need to be the same. So now if I put those two things together, that's going to give me my midpoint formula. So our midpoint is going to be equal to the point. So our x value is the average of our two original x values, and the y value for our midpoint is the average of the y's. And there's our midpoint formula. So now let's use this formula in a couple examples. So here's my first one. I have r is 1, -3, and I have s is 4, 2. One thing that may help out is just labeling these points. So the first one is our x value. So this I could say is x1. And then in my second point, maybe I'll call that x2. The y values are the second ones. So I'll say that's y1, and then I'll say that this is y2. Just labeling these points can help keep you organized, so we don't accidentally use a point twice or forget a negative sign or something like that. So again, I'll write down our midpoint formula. And now we can substitute in the values that we know. So our two x values, we have 1 plus 4 over 2. And then our two y values, we have -3 plus 2 divided by 2. And we'll just do a little bit of simplifying and we'll finish up. So 1 plus 4 is 5, so we get 5 over 2, or 2.5. And -3 plus 2, that's going to be a -1/2. So there's the coordinates of our midpoint. Why don't we take a look at a graph of this just to verify? Okay, so here's the graph of my segment RS. The midpoint has to be right in the middle. So we need to be in between the x values and in between the y values. So if I just look at this change in x, so how far it takes me to go from R over here to S, if I kind of think about this as a triangle, that difference, I'm going from this x value of 1 over to this x value of 4. So it takes 3 units to get there. Well, if I want to go halfway, in the middle, this will be 1.5 units. So that would take me up to about right here. So if I go from 1 and I add on 1.5, I get 5 halves, or 2.5. So this is at 2.5 right here. This is 2.5. And then if I think about the y values, so how far do I need to go to get from R to go up to S? So if I go this way, so here I'm going from -3, and I need to go up to +2. So that difference, this is a difference of 5 units. If I want to go halfway, half of 5 is, I'm going to add 2.5. So then going from R, adding 2.5 to get up to here, that takes me to a y value of -1/2. And then putting those together, that's our midpoint.